Hi all, this is Yashwant Kumar and my teammates Sanjana and Sai Ganesh. Uh, Here is our project. Our title is Bias Detection and Mitigation in Text Classification. Here is the project objective overview. In this project aims to address the critical issue of bias in text classification models. There are many significance like detecting and mitigating bias in text classification is crucial for ensuring fair treatment and equal opportunities. Biased models can perpetuate unfair stereotypes, reinforce existing inequalities, and result in discriminatory outcomes, which can have detrimental effects on individuals and communities. Here is the importance of bias detection and mitigation. As we know, by proactively identifying and mitigating biases in text classification models, we can promote fairness, transparency, and accountability in automated decision making systems. Here are some real world applications and impact in employment, finance, healthcare, etc. Next slide. Coming to this slide. Before previous slide, please. As you see here, the data set is obtained from the UCI machine learning repository using the provided URL. Missing values are handled using the most frequent strategy with the simple imputer, and also encoding categorical variables. Categorical columns are encoded using label encoder. And coming to numerical features, numerical columns are standardized using standard scalar. Uh, Coming to splitting the data, split data set, the data set is split into training and testing sets using train test split. As you see, the function to facilitate model training and evaluation. Next slide. Next. Yeah. Step two, coming to exploratory data analysis. Uh, as you see here, we did previous slide, please. As you see here, we did bar plot of income categories distribution, uh, bar plot of income versus features, hours per week versus income, bar plot showing income disparities. Next slide, please. Next slide. Coming to the step three, model deployment development. Here we did model training utilizes logistic regression as the chosen algorithm for text classification. And we did accuracy measures. The overall correctness of the model's prediction precision indicates the proportion of correctly predicted positive cases. Uh, Model performance display shows the computed accuracy, precision, and recalls scores, providing insights into effectiveness of trained model on the test set. Yep. Next slide. Here we see the accuracy score indicates uh, the proportion the proportion of correctly classified instances out of total instances in the test set, and precision measures the model's ability to correctly identify positive instances. And convergence warning, the message indicates that the logistic regression model did not converge within the specified number of iterations. Yep. Next slide.
Yes, coming to the step four, it's totally on bias detection. We don't give the bias on particular thing, so we have to detect equal opportunities for every group, so that we are detecting some bias classifications here. Um, uh, I'm explaining the fairness of the metrics with the disparate impact as well as statistical parity differences. It represents the differences in the proportions of favorable outcomes as well as privileged and unprivileged groups. Coming to the classes like zero while non-zero categories we are using, and also equal opportunities differences is this metric totally assesses whether the model provides the equal opportunities for the positive predictions across different groups. a value close to zero, which means signifies the fairness, while non-zero values indicates disparities. Yes, here in the bottom we can see that some values are 0.76, which is unbiased, and also the value which is a 0 point minus 0.3, which can says that there is equal opportunities between the categories variables. Coming to the statistical parity difference, as well as how the values are indicated, and EOD, which means equal opportunity difference, which I explained previously. How the exact values matches, and how the exact signifies the unprivileged group has fewer opportunities for the positive predictions compared to the privileged group. Whereas coming to the fifth step, which is bias mitigation, which means that here the code snippet defines the applications of reveining the technique to mitigate bias in the dataset. After applying the reveining, a logistic regression model is trained on the transformed data. And finally, the model performance metrics like accuracy, precision, and recall, all these are evaluated to access the effectiveness of the bias mitigation, and also some of the like which is previously discussed, like accuracy, precision, and recall. I just mentioned with numbers how it will divided, and what are the important factors we have to consider here. Whereas coming to step six, it's retraining. With retraining is the process. The model is retrained using the original data set after applying the bias mitigation. Yes, it means we have to get the original data set, because that the concept where we have to follow here, and that's the theory. Like we have to indicate that the data set is correct, as well as the process is going well, and this involves adjusting the data set to reduce the bias based on sensitive attributes like gender or race, and training a new model on this adjusted data set. And coming to the accuracy, again, I measure the accuracy, precision, and recall for after applying the some of the metrics here. Whereas my friend is going to continue.
Yeah, for model interpretation, next slide, please. As we can see here, we used a random forest classifier on synthetic data set with 10 features to train our model. The computed feature importance scores are then displayed down below, showing the relative importance of each features in the model's predictions. The importance score indicates how much each feature contributes to the overall predictive model of the performance. Um, as shown here, the trained model is the accuracy of the trained model is evaluated on the test set, and the model achieves an accuracy of 0.495, indicating its performance on unseen data. The partial dependence plots is created for feature 1, and individual condition expectation curves are then computed to show how the predicted outcome changes as feature 1 varies while keeping the other features fixed. The result shown below illustrate the relation between feature 1 and the model's prediction. Next slide. Yeah, for the visualization, the chart shown here displays the number of data points for each race category present in the data processed variable. This helps to identify any imbalance in the racial distribution of the data. Next slide, please. And we also plotted a heat map um, telling how often each predicted label corresponds to the true label in the data. Darker spots indicate a higher number of data points falling into that category. This helps to assess the model's performance by visualizing where it might be making correct or incorrect predictions. Next slide. Visualization and fairness matrices before and after bias mitigation. Here we used bar plots for this step, and the visualization compares fairness matrices for the original data and the mitigated data. This helps compare how the model's fairness improved after applying mitigation techniques. Next line. We also deployed the model in the Flask application. Uh, there, it successfully loads the trained model and listens for the prediction request on the specified endpoint. In this example, the model predicts that the given text, this job requires extensive experience in software engineering, is non biased. The JSON response includes the original text and the predicted label, providing a practical insight into the model's assessment of bias in the input text. For once the Flask app is running in debug mode and is accessible on port 500 and 5001, allowing users to interact with the deployed model. Um, that's it for our project. Thank you.